Okay, so this is section 3.4, graphs of polynomials, and it's going to build off of this end behavior stuff we saw in 3.3. And so you might want to have this out while we're working on these. So some of the techniques that we're going to use in this section is we're going to find X and Y-intercepts and use those to help us graph. Remember to find an X-intercept, or you'll probably hear me refer to it as the zeros of the polynomial. We'll set Y to 0 and then solve for X. To find the Y-intercept, we'll let X equal 0 and then solve for Y. Multiplicity is a new term we haven't seen yet. So the power that the zeros or the X-intercepts are raised to, that's the multiplicity. The sum of the multiplicities is the degree of the polynomial functions. And we saw that in the last video when we were figuring out which way the equation was going to go. So I'll use this one just as an example of that sentence. So we have this little function here. We have a 0 at x equals -3, and then we have another one at x equals 2. And because this is to the fourth, this we would say is multiplicity 4, and the 2 is to the fifth, so we'd say multiplicity 5. And then the degree would be the sum of the multiplicities, so this would be degree 9. The other two things that are really important along with this is that even multiplicities bounce or touch the x-axis, and think of x squared. So x squared is an even multiplicity with a 0 of 0, and it comes down and it just touches there and bounces back up, but it doesn't go through the axis. And so this is going to be all even multiplicities. Odd multiplicities cross, and so that's going to look like that. And so for these ones that the intercepts, the graph actually goes all the way through and comes out the other side. So that's going to be true for every even multiplicity and every odd multiplicity. So let's see what that looks like with some examples. So we have find the x and y-intercepts of this function, indicate the multiplicity and behavior of the function at each of the x-intercepts, describe the end behavior of the function. Okay, so we'll do this in parts. So first, if I'm going to find the x and y-intercepts of this thing, let me come down here and go 0 equals 4x to the fourth plus 8x cubed minus 32x squared. And so I'm letting y equal 0, which means I'm solving for x-intercepts. So 0 equals, I have a GCF of 4x squared that I can get out of there. That's going to be x squared plus 2x minus 8. And from there I can continue to factor. So multiplies to -8, adds to be 2, is going to be plus 4 and minus 2. And so then my x-intercepts are going to be x equals 0. Don't forget the one out in front here. X equals -4 and x equals 2. So that would be my x-intercepts, and I'm supposed to indicate the multiplicity and behavior of the function at each x-intercept. So for the multiplicity, I'll do that as a row across here. So this one would be multiplicity 2. These have invisible ones, so they each be multiplicity 1. And then the behavior of the function at each x-intercept would be at 0, it's an even power, so that would be bouncing. And then at -4 and 2, those are both odd multiplicities, so those are going to be crossing. The y-intercept is pretty easy this time, because if I let x equal 0, I just get y equals 0. So y-intercept is going to be 0, 0. And then I'm supposed to describe the end behavior. Coming back here, this is 4x to the fourth, which is positive even. And so basically the end behavior is it's going to look like x squared. So as x goes to infinity or negative infinity, f of x goes to infinity. And as x goes to positive infinity this way, the output f of x also goes to positive infinity. So this one is the same thing, except now it's in factored form. So find x and y-intercepts. So if I have 0 equals x cubed, x minus 7 squared, x minus 1 to the fourth, my zeros are at 0, x equals 7, and x equals 1. The multiplicities are going to be 3, 2, and 4. And then the behavior at the intercepts, this is going to cross because it's to the third, bounce because it's even to the second, and bounce because it's even to the fourth. And then lastly, oh sorry, I should find the y-intercept. And so if this is 0, 0 times negative, or 49 times 1 is still 0. So y-intercept at 0, 0. Anytime you have that coefficient x out there, it just means it's passing through the origin. And then the last thing is describe the end behavior. Remember, we can get the degree of the polynomial by adding the multiplicities. So that's here, here, and here, which is what I need to do to find the end behavior. There's no negatives on any of these x's. That makes it a positive x. And then 3 plus 2 plus 4 would be x to the 9th. And so it's going to have the same end behavior. I won't write it out this time, but the same end behavior as x cubed. I'll just verbally, as it goes to negative infinity, the outputs go to negative infinity. As it goes to positive infinity, the outputs go to positive. So this next question is to find an equation in expanded form. That means we have to FOIL it out. That has solutions of x equals 2 multiplicity 1 and a solution of x equals negative 3 multiplicity 2. So if it has a 0 of x equals 2, then it has a factor of x minus 2. Multiplicity 1, so it's to the first. So remember, the 0 and the factor always have opposite signs because we set it to 0 and we add over to get the 0. And then we have a solution of negative 3, so that means we have x plus 3, put negative 3 in, it makes 0. And multiplicity 2, so quantity squared. And then important equals 0, because it can't have zeros unless it equals 0. So you'll need to type that equals 0 on the computer. To finish this out, I think I'm going to expand this first, and I'm using special products. If you're not great with that, then go ahead and write them side by side, and you can do out your FOIL to get the same thing. But this will be x squared, and then 2 times x times 3. I'm doing the 2ab in the middle for plus 6x, 3 squared for 9. And then from there I just FOIL this. So x times x, x cubed, everything gets x bigger, so this is plus 6x squared plus 9x, and then negative 2 to everything. So negative 2x squared minus 12x minus 18 equals 0. And then lastly, I just have to collect my terms. So x cubed there. For the squares, I got 6 minus 2, so I'll be 4x squared. And then 9 and 12, so I'll be minus 3x minus 18 equals 0. So this next part is actually graphing the polynomials, and this is kind of what this has all been leading to. So our first step is to determine the end behavior of the function. So if the function is factored, add the powers and find the leading term. And so with that, we're going to look at the degree and the coefficient, and that's going to tell if it's positive, even, positive, odd, negative, even, negative, odd. And then if the function isn't factored, use the leading term to find the end behavior. And then 2, we'll find the x and y-intercepts, and we're going to determine bounce cross that we just saw, and that's at multiplicities, even powers bounce, odd powers cross. And then we'll use that information to draw a smooth curve of the function. And then just a note, so these problems are not on the computer homework, the version where we have to actually draw them ourselves, because they would be terrible to draw on a computer. This is a section where you should absolutely check out the graphing supplement, because that's going to be how they appear on the test. Okay, for this one we're supposed to complete steps 1 and 2, which was back here. And this is where we first find the end behavior, and then second we find the x and y-intercepts and determine cross and bounce. So for this one, the end behavior is going to be negative even, or like negative x squared, because we have negative x to the 4th. And so we'd expect our graph, it's going to do other stuff in the middle, but it's going to come in from the bottom, and it's going to leave out from the bottom. And so what this end behavior does is tells me where to start the graph and where it should, which way it should end up going. And then to find the x and y-intercepts. So the y-intercept, I have x's in every term, so it's going to be 0, 0, because when I let x equal 0, y is 0. For the x-intercepts, that I got to do a little bit of factoring. So negative x to the 4th plus 4x squared equals 0. And I'm going to take a negative x squared out of those, That'll leave me x squared, and then minus 4. Make sure you get that sign flip there. And if I finish this out, I have negative x squared, x plus 2, and x minus 2. So my zeros are going to be at x equals 0, x equals negative 2, and x equals 2. And for the squared one, that's going to bounce. For these two, they're both to the first. So it's not the number that's even, it's the power, right? So these are odd powers, so they're both going to cross. And then what we do is we use that information to get the graph. So let me show you what that'll look like. I always start by graphing my intercepts. So I have one here at 0, 0, at 2, and at negative 2. In this case, I don't have to label the y-axis because it just is 0, 0. So that's pretty easy. And then the question is, do I start the graph from down here or do I start the graph from up here? Because I already know what it's going to do with these intercepts. And that's where end behavior comes in, is the graph has to come in from the bottom. So this one's going to come in from the bottom. At negative 2, it's going to cross, so I have to go through that one. It's going to have a turning point and then come back and bounce off of 0. So it's bouncing right there. And then another turning point, and then it's going to come back and cross through 2. And so even though the middle of the graph doesn't look like negative x squared, this part does. And so if we zoom back far enough, it has that same shape as negative x squared. So that's graphing polynomials. I'll do some more examples, but it's all basically, this is kind of what the section's about, and this is what you would see on the exam. So this one, it's already factored. So to get the end behavior, we have to add up the multiplicities. So that's going to be x cubed, or like x cubed, it is x cubed. So it should look something like that. Again, we can get different stuff in the middle, but it's going to come in from negative infinity and leave out positive infinity. And then since it's already factored, our zeros are easy. X equals 2, x equals negative 2, and x equals 5. So that's going to be, everything's crossing because they're all to the first. And then this time the y-intercept does something different because I don't have that x out front to zero it. So y equals 0 minus 2, 0 plus 2, 0 minus 5. So that is really negative 2 times negative 5. So that is going to be positive 20. So when the x is 0, the y is 20. And so on the test, I don't generally ask for this. I think on the homework it might have you identify some y-intercepts. And so this is just going to be, if I label this, 5, 10, 15, 20, I'm just going to count by 5s, and I'll let that be 20. The x-intercepts I got at 2, or negative 2, positive 2, and positive 5. 4, 5. So then drawing a smooth curve through that, we have to come in from the bottom. Everything's crossing. So it's going to come in from the bottom, go through that y-intercept, come back, and then go back up. I mentioned in the directions, don't worry about the height of the turning points of the mins and the maxes. And that would be like these things right here. Pretty much we need calculus to figure out where those are in any sort of efficient way. So we're just kind of doing an approximation on this, which is often good enough just to sort of know what the behavior of the graph is. Okay, so this one, end behavior, it's going to be like x squared because it's x to the fourth positive even. So we expect it to look something like that. The y-intercept, if I let x equal 0, then I get negative 16. So it's going to be 0, negative 16. And then for the x-intercepts, that I have to do a little factoring. So if I factor this out, I get x squared plus 4, x squared minus 4. And then this piece goes one more round. This piece doesn't. It's a plus, that makes it prime. So that's going to be x plus 2, x minus 2. So here, if I try to solve this, and if you can see already, it doesn't have real solutions. You don't need to go down this road. But let me just kind of show you why this doesn't contribute to my x-intercepts. When I bring that 4 over, I get a squared equals a negative. And if I kept solving from there, I would get x equals plus or minus 2i. So this piece has imaginary solutions, so they don't make intercepts on the real graph. Here, negative 2 and 2, those are going to be my real ones, so those are both crossing. So I'll label this, negative 16 right there. Let's do 4 boxes. And then I'm going to have intercepts on the 2's. And so this thing looks something like x squared, but it's a lot steeper because it's x to the 4th. Okay, one more example of these. So here I have a negative, so for my end behavior it's going to be negative, and I have 1, 2, 3, and then 4 more would be 7, x to the negative, x to the 7th. And it's negative, so that means it's going to look like negative x cubed. So I should be starting up here and ending down there. So let's see, we got the 0, this x out front, so that means our intercept for the y is going to be 0, 0. And it's factored, so I can just grab my x-intercepts pretty easily. X equals 0, x equals 3, x equals negative 3. The 0 is squared, so that's going to be a bounce. It's going to be a cross on this one, and a bounce on the 4th. Sorry, a bounce on the 4th power to the 4. And so then, come over here, we'll draw on our intercepts. So negative 3, 0, and 3. Graph's going to start at the top and come down. And at negative 3, it's supposed to bounce. So we'll bounce off of that one. At 0, it's supposed to bounce. We're going to bounce again. And then at positive 3, it's going to cross. So that gets my graph going out the right direction as it should. Again, these points are totally approximated. They're probably exaggerated or not, who knows, just so you can kind of see them. But I'm not worried about where the height is when you're sketching this on the exam. Just draw me something clear that I can see you knew it should, bounce and cross, come in the right way and goes out the right way. And then these last two examples are going kind of backwards. We're given the picture and we're trying to find the equation. And so, and it says assume all multiplicities are either 1 or 2. So if we see something bouncing, we can assume it's multiplicity 2. If we see something crossing, multiplicity 1. So for my x-intercepts, I have x equals negative 4, and that's going to be multiplicity 2 because it's coming up and bouncing. For my second one, I have, that's x equals negative 4. And then for my second one, I have x equals 1, and that is multiplicity 1. And so this is going to produce, and the y-intercept I should write down, is at 0, negative 8. So what that means is I'm going to have a function of the form y equals, there could be a coefficient out front. It could be positive or negative. We can kind of look at the graph and know it's positive, but it could have like a number in front that's making it kind of stretch or shrink and still have these same intercepts. So we're going to let that stand in as an a and then try to figure out what it would be. I have up here, I wrote it really badly, but it's x equals negative 4. So that means I have a factor of x plus 4, and that's multiplicity 2. And then here I have a factor of x minus 1 because it's multiplicity 1 at 1. And so then once I have this, there's my form, and I have this point, which is an xy. So I can take this and toss it in for my x's and y's and use that to get at my a. So y is negative 8 when the x's are 0. So this is going to be 16 here, and then times negative 1, or negative 8 equals negative 16a, and then dividing the negative 16 over, I get a equals 1/2. So then my final answer on this is going to be y equals 1/2 x plus 4 squared x minus 1. This one's the same, just a little bit different shape. So for x-intercepts, I have x equals -2, and that is going to be multiplicity 2. X equals 1, multiplicity 1, and then 4. Also multiplicity 1, and that's because these two are crossing and this one is bouncing. And then my y-intercept I'll use to find a is 0, 2. So getting this set up, I'm going to have y equals a, and then x plus 2, that one will be squared, x minus 1 to the first, x minus 4 to the first. And then I just have to toss the 0, 2 in and see what it does. So and that will get us our a. So 2 equals a, and so this time I'll just write it as 2 squared times -1 times -4. So let's see, 2 negatives, that'll be positive, and 4 times 4 is 16. So 2 equals a times 16, divide that 16 over, and I get a is 1/8. So final answer on this one would be y equals 1/8 x plus 2 quantity squared, x minus 1, and x plus 4. So make sure to check out the graphing supplement so that you get some practice with these as they appear on the exam.